So let's say we have a data set with points, and now we suspect there is a linear correlation. How can we find a straight line that best describes these data points? So should it be this one, or perhaps that one, or this one? So which one should we choose? The line that best describes these points is called a regression line. And as all other straight lines, we can express it as this, where k is the slope and m is the crossing on the y-axis. So now we want to determine the slope and this constant m that best describe these data points. We see that for every point there is some error, that it deviates from the line somewhat. So this distance here we call the error. So if this is the data point xk, yk, then the error is yk minus the y-coordinate here. And since it's on the line, we call it y. So yk minus y is this green distance here. So how can we minimize the errors? We cannot just sum the errors, because some of these are negatives and some are positive, and then will cancel if we add them. So we need to get rid of the signs. And one way of doing that is, of course, taking the absolute value. But what is normally done is to take the squares. So you square the coordinate difference here instead, then you get rid of the signs. And then you add all the errors. So the total error becomes this, if you have n points. Then you want to find the line that minimizes this total error. And that's a mathematical problem. That's called the method of least squares. We will not go through the mathematical details, but just to give the answer. So we will see what k and m will be for the line that minimizes this here. Then the solution to this mathematical problem is given by this. So the line that best describes these data points has a slope of this one and intersection with the y-axis this one. And here xi, yi are the coordinates of the end points, and x bar and y bar are the means. So you basically see here that we have the covariance divided by the variance. And once we have calculated the slope, we can put it here and calculate the intersection m, and then we have the straight line. So let's see an example of that. So we want to find the regression line that best describes these 6 data points. Then first we calculate the means of x and y, just adding all the x coordinates. Dividing by 6 gives 15. And same for y, add all the y coordinates, gives a mean of 3. Then we can put that into this formula. So for the first one we put 10 minus 15, that's minus 5. And 2 minus 3 here is minus 1. So this is for the first point. And then we do the same for all the points. And then we calculate this one. And also here we can just copy the numerator, because these numbers here are the ones we are supposed to square. And just adding this up, we get 1671s, roughly equal to 0.23. Then we can calculate the intersection m, the mean 3, minus the k we just calculated, times x mean 15, giving minus 2771s, approximately equal to minus 0.38. Then we get our regression line. We take k, the slope is 1671 times x, plus m minus 2771s, or round off to 2 decimals, this one. So this is the regression line we are seeking. That's the straight line that best describes the data points.